So this test is officially on compositions and inverses. Okay, and if I were to pick one thing that would be the most important topic as far as doing well on this test, I would say it is inverses. But you got to know a lot of little pieces to do inverses well. You got to be able to do common denominators. Okay, so because in the middle of doing a proof that two things are inverses, you might have to find a common denominator. So there's like little pieces that'll be important to do the inverses, but first let's just get a general idea. What is an inverse? So let me show you. Here's a picture. Imagine for a second you have a graph and it looks like this. And I'll give you the line y equals x just for a perspective line. Imagine that was the line y equals x and I got that red graph. What would its inverse look like? I'm going to pause for a second while you, oh here, I'm going to give you a few points. And you know, like you could always make up points for yourself. I would hope you would know that a point up here could not be like 3 comma 3 because it's the line 3 comma 3 would have been on here. You know what I mean? It would have been on that dotted line. Okay, so this should be like maybe 2 comma 4 up here. And then we'll make this spot here be like, I don't know, if I said that's over 2, then maybe that's over 4 comma 0. All right, so there's a few points that are on it. Why do those points help? Because what's the number one thing that you need to know about inverses? X and Y switch. And that means domain and range switches too. Okay. First thought, 0, 0 will be on both graphs. Because, why? Well, anything on that line, anything on this line is going to be still on the reverse of the two, because 0 comma 0 reversed is still 0, 0, right? Okay, so if I say this is the spot, I don't know, 3, 3 or whatever it is, it's going to stay the same. It'll be on both. So then it's going to go like that. Raise your hand if you had it something like that, like the green one. Okay. And what are some points that are on it? Well, instead of 4, 0, I have 0 comma 4. And instead of, and again, this 0.24 was probably not a great point. I should have probably said that that was over 1 comma 3 or something like that. That would have been a more logical number to pick because it's higher than it is wide. So anyway, then the 0.3 comma 1 would have to be on it, which would be like somewhere in here. Notice straight across this line. Why straight across the line? Because it's a reflection across that line. How about these points? They're a reflection straight through the line of each other. Okay, so that's picture-wise kind of how it should look. And you also get a little flavor of the whole X and Y switch thing. All right, let's do a little more complicated inverse question. Let's say I give you these inverses. And by the way, this is going to need you to know how to do common denominators. So I'm just going to take 2 seconds and talk about that. What if I have 1 over x plus 1 and I add 3? If you can't do the common denominator for this, then you're not going to be able to do well in this test. So I'm going to help you right now to get a common denominator. Everybody try it, and then we'll know who's in the haves and who's in the have-nots category when it comes to denominators. Guess what? It's one of the top 20. Because common denominators for little simple fractions are the same concept. I put this over 1. And did you multiply both of them by x plus 1 on the top and the bottom like this? Raise your hand if you knew that that's what you should do. Okay, good. So most of you are with me on this whole common denominator thing. 1 over x plus 1 plus 3x plus 3 over x plus 1. What did I do? I distributed that. And now I could put it all together, and I could say 3x plus 4 over x plus 1. Raise your hand if you had that one right. Okay, good. So we got common denominators down. Now let's use them. If I said f of x is 1 over x plus 1, would you please find the inverse of that? I could say f negative 1 of x, and that would tell you I want the inverse. Or I could just tell you verbally I want the inverse. What's the inverse of 1 over x plus 1? There's more than one way to solve this, but step 1 is to say y equals 1 over x plus 1. Why is that? Because then you want to reverse the x and the y. X equals 1 over y plus 1. And now, some people get stumped. Say like, I haven't ever solved something like that before. But I have told you to clear fractions before. Mr. H, what could I multiply both sides by that would get the fractions out of there? Exactly. That's one of those themes of pre-calc, is you got to clear fractions out. And it's not just pre-calc, it's when you hit algebra, sorry, it's when you hit calculus too. Whenever there's fractions, you try to clear them. Because nobody likes dealing with fractions. Even the calc teachers don't like having to deal with them, so they clear them out. Now, I have two thoughts on this. One kid last hour said, but Mr. Server, at this moment, I did it different than you, and I like my way better. And I'm like, it's totally fine. What would be a way to solve for y at this point? Give me a way. You can't do it all in one step, by the way. What would be a step I could do that would get us closer? Yes?
Divide by x.
Divide by x. That would work, but stop. What's a different way? Yes?
If you distribute the x.
You distribute out the x. Is either one of them better than the other? No. You could do either one. Okay? I'm going to distribute out the x and say it's xy plus x equals 1. And just show you this way quick. Then I would subtract x from both sides. And now I got xy equals 1 minus x. And then I just have to divide both sides by what? By x. There, that worked. What did I get? 1 minus x over x. I'm going to write that down over here. 1 minus x over x. That's what I got. Now I'm going to go back and do it the other way and just show you. You could have done it this other way and it'd be fine. You could have divided both sides by x. That cancels. Y plus 1 equals 1 over x. Now I'm going to subtract 1 from both sides. And the question was like, wait a minute, that looks different. 1 over x minus 1 looks different, doesn't it? But it's not different. How is this actually the same as that? Well, if you take this one and you break it into 2 divide by x's, do you get how it'll turn into 1 over x minus x over x? And then do you get how that's actually the same as this? See what just happened there? I just took this and divided it as 2 separate divides. There's all this algebra that we kind of assume that you know. I'll show you that again. Say I had 7 minus a over 4. Do you get that's the same as 7 over 4 minus a over 4? We just kind of assume that you can know that and you can do that. That is not one of the things on my top 20, but it could be, because this is a really common one where people don't know this. Okay, so then I'm going back to this problem we were in the middle of, and cool, I've got my inverse, because either way I can say it's 1 over x minus 1, or I wrote it down before, it was the same thing, it just looked different. All right, I'm going to stick with this one. So if that's my inverse, did you see where I needed to find common denominators to be able to do it? Maybe not, but you will when we try to prove these things are inverses. All right, so here's your two functions. The starting one up here, 1 over x plus 1, and 1 over x minus 1. Here, I'll write them as separate functions, and maybe you should do this too. If f of x is 1 over x plus 1, and the new function we made, we'll call it g of x. G of x is 1 over x minus 1. Does anybody remember how to prove that they're inverses? Yes, sir.
You f of g of x and then g of f of x is they both simplify to x.
G of f of x. If they both equal x, then you've got proof that they're inverses. You are correct. It'll be during this process that you will need to find a common denominator. Everybody, take the time. Do you need some paper?
No, I don't.
It's a week. All right. Take the time to show the steps on this thing. They make the f function eat the g function. Simplify it down. You'll end up with common denominators. And at some point, when you're doing f of g of x or g of f of x, common denominators will come in handy. All right, I'm going to pause for a second while you give this one a try. Okay, let's see how you did. This one simplifies down, and you may remember me telling you that I would be looking at the work carefully, because we all know it comes out to x. You can't just say, comes out to x. Look, see, cancel, 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 cancel. The answer is x. No, you can't do that. You have to show how it becomes x. So where should I start? On the top? There's nothing to do on top. There's just a 1. So you got to start down here, right? Now, can I just let this minus 1 and plus 1 cancel? Yes, I can. I don't have to go get a common denominator to cancel those. They're exact opposites. I can just cancel them. Now it's just 1 over x. Do you know that that means 1 divided by, which is the same as times by, flip it over, x over 1. So therefore, it is x. Yay. But Mr. Server, I never needed to use a common denominator there. True. On that one, you didn't. Now let's do the other one. G of f of x. All right, here's the g function, 1 over x minus 1. And it's going to eat an f of x function, which is right there. And then I have 1 over x plus 1. Oh, crap. This one doesn't need a common denominator either. Okay. If you know what this means, you won't even need to use a denominator. You can do the flip and multiply thing. And it ends up being x plus 1 over 1 minus 1. And yes, this cancels. Just as simple as that. There's no common denominator needed for this one. Darn it. Well, I can tell you that when you do the one on the test, you will need a common denominator. So I'm going to give you one more that has a common denominator for sure. Okay? All right. So here's the one with a common denominator in it. I'm going to just make it simple. Here's f of x, and it's 6x minus 3. Here's g of x, and it's 1 over x plus 4. And the question is, what's f of x minus g of x? And hint, you can't do this one properly without getting a common denominator. Because you're subtracting. The other one, you could pull the whole flip and multiply deal, and the fractions just ended up canceling and working out really nice. This one, you'll need a common denominator. So often, it's not the actual pre-calc concept. It's a little dumb thing like common denominators with variables that gets you. Okay. So you should have said 6x minus 3 minus 1 over x plus 4. And then I'm going to multiply both sides, or sorry, both parts of this top and bottom by x plus 4. That gets me a common denominator. See, they're the same now. Now, I'm going to have to distribute And I have an x plus 4 times a 6x minus 3. I'm going to just do each part one at a time. X times the 6x, 6x squared. X times the negative 3, negative 3x. 4 times the 6x, 24. 24x. And then 4 times the negative 3, negative 12. And then a minus 1 at the end. Don't forget that guy. All over x plus 4. Simplify it down. 6x squared plus 21x minus 13 all over x plus 4. And then if you can factor it, you should. You know why? Because sometimes something like that will factor and then the x plus 4 cancels. This one can't factor. Therefore, I'm done. Okay. Yay. We just added the two functions together. Now, what's their denominator? No, what's their domain? Don't worry. We're only halfway done. So what's their domain? Well, I'd need to know the domain of the two original ones. What's the domain of this one? All reals. What's the domain of this one? Everything except negative 4. When I overlap those two, all reals is like a number line with everything shaded. Over everything but negative 4. It's like that. Where do they overlap? Well, everything except negative 4. So you could say negative infinity to negative 4, parenthesis, union, negative 4 to infinity, parenthesis. There we go. I didn't need any big fancy formula. On what kind would you need a big fancy formula? Oops, sorry. F of g of x. All right, let's do one like that. Are you ready? Let's say I had f of x was square root of x minus 1. And g of x was 3x, but x has to stay less than 5. And that's a given domain. Like they just say, that's the way it's going to be. I know this normally would be all reals, but I want you to use x is less than 5. Okay, now find f of, no, let's do it backwards because I want you not to get stuck on thinking f's always on the outside. This is not. G of f of x and its domain. I'll pause to give you a second to try that one. All right, so let's see what you did. Hopefully you put the f function inside of the g. Here's a g function, 3 empty spot. And I'm going to put in the other function, square root of x minus 1. Now, can I multiply that in? No. You have to leave it as 3 root x minus 1. Sometimes the trick is knowing that you can't simplify it. Okay, next, the domain. I hope you took the inside one and did domain of f intersected with same function, but the actual function f of x in domain of g. Raise your hand if you had the right formula for yours. Okay. Then, what is domain of f? I go back and look at the original, and Mr. Server, you never told us the domain of f, but you can figure it out because it's what's called an implied domain. And you'd say x minus 1 greater than or equal to 0, x greater than or equal to 1. So that's this one. So, what else do we have to know, Mr. Server? Well, let's talk about this next. Do you remember the difference quotient? Let's do that with a simple one. Let's say the function is 6x minus 5. Can you do f of x plus h minus f of x all over h? Hint, start by just putting that into the f function. And I'll pause while you give that a try. Okay, so you should put in that is my function, and it's going to eat that. 6 parentheses x plus h minus 5. Now I'm going to have it subtract f of x, but I'm just going to right away put in the f of x in parentheses. Did anybody forget that parenthesis there and therefore forget to distribute the negative? Because that would be trouble. All over h. Now I'll simplify it down. 6x plus 6h minus 5 minus 6x plus 5. 6x minus 6x cancel. Minus 5 plus 5 cancels. 6h over h, h's cancel. The answer is 6. And if anybody remembers that this is actually a really complicated slope formula, you could have said, oh, it was right there the whole time. Yes, but where we use it is oftentimes has an x squared in it, and the slope of something squared is much more complicated. This formula can handle finding the slope of things when they're squared, too. Okay. All right, so that's called difference quotient. Any more questions on that one? Okay. Next, we're getting near the end of the hour. I'm just going to keep on working to the end of the hour, but here's my point. What do you do tonight? Well, remember, we don't have a review worksheet for you. What I gave you is the closest thing we had. It was like a formative from last year. Okay? And not everything that was on there is on your test. So don't think like, oh, I have to know everything from that sheet. No, you don't necessarily. There was one, for instance, where you had to do an inverse of something that was squared, and it ended up really complicated, and you don't have to do that kind. So don't stress about the hard problem. All right? One more thought. What else could you do to study? Well, I did do a review, not yesterday because I wasn't here, but the day before that. That had a lot of review in it. You could go back there. What else could you do? You could come in tomorrow morning. It's a Thursday. I'll be here. If you want extra help in the morning, you can. Option C, you can rewatch this video. If you've been having a hard time paying attention because you're in a food coma after lunch or whatever, I'm going over the things that I think are the most important, and I'm not just like picking things randomly. So, all right, next, let's talk about a inverse and its domain and range. Let's just start with a regular function and its domain and range. Do you know what this one's domain and range are? Don't worry about its inverse yet. Just find the inverse. Sorry, just find the domain and range of that. Hint, draw a picture. We expect you to know what square roots look like. And x squared, we'd expect you to know what that looks like. Raise your hand if you had the domain and range right on the original. Okay, now here's my question. Find the inverse, and before you even find the inverse, you could tell me the inverse's domain and range right now. You're not going to even look at the inverse to find the domain and range? The inverse's domain and range are just the original two, except what was the one thing that was important about inverses? What switches? X and Y switches, and therefore the domain and range switch. Do you get the domain just becomes the range, and the range just becomes the domain? That's all there is to it. then do you even need to find the inverse? I think that we will ask you for the inverse. And that's a three-step process. First you change it to y equals. Then you switch x and y. And then you square both sides. And then we're adding 4. Now here's why you don't want to just look at the inverse. Do you get, if you looked at that inverse, you'd have said, oh, it's a parabola shifted up 4, so I know its domain and range. No, you don't. Not unless you look at the parents. Because look, wouldn't you have said the domain of that was all reals? But its actual domain is from 0 to infinity? That's a big difference. Why is that? It's like you go to the doctor and you ask the doctor, do you think that when I'm 40 I'm going to get cancer? They're not going to check you right now. They're going to ask you what your parents had. They're going to look at your parents. Just like this, you look at the parent functions, the ones that made up this new function. You look at the two parents. So in this case, you look where it came from. And it came from this. Do you get, if you used a number, if you use the wrong number, you're going to crash this function? That's why this function would crash even though you don't think it would, because it came from this. All right, if you don't understand why, just trust me on this. When you get your inverse, don't look at your inverse to get its domain and range. Don't look at this. You do look here to find the domain and range. So I have one more that I think would be smart for you to contemplate. I'll give you a super simple one. I should call it f of x because I want to have you find its inverse. If this is f of x, if I asked you for f of 7, you should be like insulted. It's too easy, right? What's f of the inverse of 7? Do you get, you better figure out the inverse of f of x first? So the inverse of this, y equals x minus 3, switch them around, x equals y minus 3, add 3 to both sides, y equals x plus 3. Pretty straightforward inverse. Or f of x. Except it's not f of x, that's f of x. So this is f negative 1 of x is x plus 3. Now we're going to stick in a 7. And what do you get? 10. Then a 10 goes right here. Now it's just f of 10. And f of 10 is 10 minus 3. It's back to 7 again. Did anybody think that that might happen? Like, I was thinking it through, and I'm like, ooh, they're inverses of each other. And when you have an inverse of an inverse, you're supposed to just get x. Oh, I got just x. Be honest, how many of you had 7 before I said it? Oh, that's almost everybody. Okay, good. Okay, so we've done enough practice here, but have you done enough practice to do well tomorrow? Remember, there's always problems we skipped before. Those would be good ones to do. You can watch this video over again. You could come in the morning. Lots of options. I'm excited to see how you do tomorrow.
Thank you.
Yep. Have a great day.